Solving trigonometric equations. Sometimes in Core 3 you can be asked to solve trigonometric equations using the identities that we've learned so far in Core 3. And we're looking to find out what sine theta is and what cos theta is, or maybe even what cos 2 theta is equal to, etc. So, here we're given that x is equal to 3 sine theta and y is equal to 3 minus 4 cos 2 theta. And we're told by eliminating theta and expressing y in terms of x. So what we're asked to do, we're asked to eliminate the theta from both equations and to have y in terms of x. Now what this tells me in the question is that we want y in terms of x. So that probably means we're going to need to rearrange this initial equation to make sine theta the subject. And in some way we're going to substitute that into our other equation to eliminate thetas. So firstly, if we rearrange the first equation, if we divide both sides by 3, we've got x over 3 is equal to sine theta. And if we look at the other equation, we have y equals 3 minus 4 cos of 2 theta. Now, earlier on in Core 3, we've looked at other ways of expressing cos equals 2 theta. And one of the ways we did was cos 2 theta is identical to 1 minus 2 sine squared of theta. And if we substitute that in replacement of the cos 2 theta, we'll have y equals 3 minus 4 1 minus 2 sine squared theta. Now, we've now got sine squareds here, theta, and we have sine theta. So it probably means we're going along the right line to eliminate the thetas. If we first expand the bracket, we're going to have y equals 3, minus 4 times 1 is minus 4, and minus 4 times minus 2 is 8. So we're going to have 8 sine squared theta. And if we just tidy that up, 3 minus 4 is minus 1, plus 8 sine squared theta. Now, we have sine squared theta. Remember that sine squared theta we could also write as sine theta squared. Well, funnily enough, we know what sine theta is. So if we put that in here and square it, we can replace that. And if we do that, we get rid of all thetas in our question. So y equals minus 1 plus 8 x over 3, because that's what our sine theta is equal to, squared. And at this stage, if we just tidy up finally, y equals minus 1 plus 8x squared over 3 squared, which is 9. So now we have an equation for y in terms of x with no thetas in it. So in this question, what we've had to do is we've had to rearrange one of our two equations given to help us eliminate the thetas. If we have a look at a second example, it says solve 3 cos 2x minus sine x plus 2 equals 0 between 0 and 360 degrees. Well, the problem here is that we've got cos 2x and sine x, and to help us solve this question we need to have either sine x's or cos x's. Well, like in the previous example, we know that cos of 2x is identical to 1 minus 2 sine squared of theta. That's identical to cos of 2 theta. Okay, so if we replace our cos of 2x with 1 minus 2 sine squared of theta, we're only going to have sines in our question. So it's going to be 3 times 1 minus 2 sine squared of x, because we're looking at x rather than theta in this question, minus sine x plus 2 equals 0. And if we expand both sides of the bracket, we get 3 minus 6 sine squared x minus sine x plus 2 equals 0. Now it's not very helpful having a minus sine squared x, so I'm going to move everything to the other side of the equation. So we're going to have 0 equals 6 sine squared x plus sine x, and it's going to be 3 had 2 before and was 5, so it's going to be minus 5. Now at this stage you should be able to factorise this quite nicely to 0 equals 6 sine x minus 5 and sine x plus 1. And remember, the only way to get 0 when multiplying two numbers together is to have each bracket equal to 0. So we're going to set each bracket equal to 0. So from this bracket, where is sine x equal to minus 1? Which will be, so x is going to be at 270 degrees. Remember, we're working in degrees and not radians on this question. And the other one is going to be where sine x is equal to 5 over 6, which is at x equals 56.4 degrees. And if you remember the sine graph, it goes up and down between 0, 180 and 360. So the other solution is going to be 54 degrees in from 180. So we do 180 minus 56.4, we get 123.6 degrees. And they are our three solutions between 0 and 360 degrees.